Amazing. So I think we are. Hi everyone. This is Chris from DoraHacks. It's great to see you guys again. I'm gonna be the moderator for today's workshop sessions. This is actually the very first workshop sessions for Algorand Buildable Hackathon. And it's actually also the very first time for DoraHacks to support the Algorand developer initiatives. So it's a very exciting moment. The hackathon has already started. The registration form even start longer before. But basically right now, if you are developers and want to build something cool in the Algorand ecosystems, you can go to DoraHacks platform. You should first try to register through the Algorand official registration form of the hackathon. You can see at the very top in the detail tab of the hackathon page, there's a hyperlink that can direct you to the registration form. And after you complete the registration form, then you can submit your actual project through DoraHacks platform, and the actual project will be the final submissions for your project and will be reviewed by judges. And yeah, today we are very excited to have Joy from Algorand Foundations to join us as the first workshop speakers. And he will give, I would say, Algorand Developer Beginner Sessions 101 for everyone who are interested into build on Algorand ecosystems. So I will just give the stage to Joy right now. Joy, feel free to start when you're ready.
All right, great. Thank you. Thanks for having me here. So today, like Chris mentioned, we're going to be going over the beginner bit concepts of how to get started developing on Algorand. So I'm going to assume not everyone here is super familiar with Algorand. So I'm going to start with kind of the very basics, and then we'll go over into some resources and the tooling that you'll use to build on Algorand and show you what that actually looks like. So by the end of this session, you'll have a pretty good idea of where to get started and the resources that you can use to continue your learning journey between now and the end of the hack. And then, of course, we also have a intermediate session as well. So what I'm going to be starting with is talking about our developer portal. So if you come to the developer.algorand.org, this is what we call our developer portal. And this is the page I have here. This is kind of our home base for everything dev related. So this will talk about, as you can see here right on the landing page, it starts all the way from blockchain basics. And then we have in-depth documentation on all the Algorand primitives that you have available to you. So this is a great resource for any questions you have about Algorand in general. The dev portal is the place to go. Now, for those that aren't familiar with Algorand, Algorand is a non-EVM chain. It's its own layer one, so we don't support Solidity. And this means that the developer experience is on Algorand is a bit different than it is on EVM chains. So that's really what I'm going to be focusing on today. Now, there are various ways to learn about how to get started. You can go to our documentation. You can read the documentation on our individual GitHub repos, but kind of the best comprehensive way to get started is via our boot camps. Now, obviously, today, I only have about, I think, 30 or 40 minutes to go through this session, but you need a little bit more time to really get started building on Algorand. So we have full workshops, a beginner and an intermediate level boot camp available on GitHub. So this is what I recommend going to get started. And to go to them, you just go to github.com/Algorand-bootcamp. So going to github.com/Algorand-bootcamp will bring you to this Algorand bootcamp content org. And here in the README of the org is links to all of our bootcamp content. Now you can see here that we have right now a single flavor of bootcamps, if you will, for our full stack TypeScript, which I'll be going into the details of this in a bit. But the idea here is that you're using TypeScript to write your contracts and using TypeScript to write a front end. And by the end of the bootcamp, you have a full stack DAO. So here you can see in our beginner, we have 4 individual sessions that each about hour and a half. Then, of course, all the code is open source. We have that for English and Spanish, and then the same thing for intermediate as well. So what I'm going to be showing you today is how to get started getting set up for the beginner bootcamp. And I'll briefly go into some of the beginning concepts that's important to know as you go into the beginner bootcamp. So I'm going to start by coming down into my full stack TypeScript bootcamp, beginner, English, and then head to this repository here. Let's see, it's TS beginner EN, meaning TypeScript, beginner, English. And to get started here, you can clone locally, but you can also start a code space. Now, in order to start a code space, you have to make sure you're logged in. So definitely make sure you're logged in to GitHub before doing this. If you don't yet have a GitHub account, it should be pretty easy to make. And once you're logged into GitHub, come over to the TS Beginner EN repo. As you go to this code dropdown, you should see a similar UI. You probably won't have existing instances. But the important thing here is if you click on this plus button, that'll start a code space for you. And what this code space is going to do is it's going to launch a virtual environment that has all the developer tooling for Algorand pre-installed. So for Algorand, the main tool that you use throughout development, whether you're just getting started or you're ready to deploy to production on mainnet, is a tool called AlgoKit. AlgoKit is a combination of a command line utility and SDKs that, again, is used throughout your development journey. And in order to get AlgoKit up and running, you need a couple of requirements. Namely, you need Python 3.10 and you need Docker. Now, because Docker can be a bit cumbersome to install, it's normally easier to get started on code spaces if you don't yet have Docker installed on your local environment. With code spaces, you get, I think it's 60 hours for free. So it's a great way to kind of just get a feel for what development on Algorand looks like before you set up your local development environment. So we can see here what is happening in my code space is it's installing the tool AlgoKit, and then it's running this command AlgoKit localnet start. I'm not going to go too in depth into what that is right now. Before I'm going to show you some other AlgoKit commands, and then we'll come back to what localnet actually does. So I'm going to open up a new terminal. Let me zoom in here so it's easier to see. Sorry, I forgot to do that. Start. Now at this point, this looks like just regular VS Code, except we're actually, you can see here that I'm still in my browser. And so basically this is a VS Code window in your browser connected to a VM in the cloud. That's everything set up. So if I go ahead, I'm just going to close out of this for now. And I run the command AlgoKit. What that will do is it'll tell me a little bit about AlgoKit, give me a link to a tutorial, what options I have, and then all the different commands we have available to us. You can see here, there's a bunch of different commands that we have at our disposal. And today and in the bootcamp, we'll be focusing on a couple of them. So the first command I want to talk about is this init command. And this is what you're going to be using to initially get started with your project. So once you have AlgoKit installed, in order to actually start building, generally the first command you want to run is AlgoKit init. And as you can see here, this will initialize a new project and initialize the project based on a template. I'm going to go ahead and clear my terminal. And then I'm going to run AlgoKit init. And what that's going to do is ask me to select a project template. And the one you want to select now, if you're just getting started building on Algorand, is this TealScript option here. This is, as the description mentioned, the official starter template for TealScript applications. Now you might be wondering what TealScript is. and TealScript is a TypeScript compiler for the Algorand VM. So I'm going to go ahead, select TealScript. I'm going to give it a name. I'm going to call this TealScript demo. And then once I give it a name, it's going to create the project. And then it's going to ask me if I want to install the dependencies. I'm going to go ahead and click yes. And so what AlgoKit is now doing, it not only set up my project, but it's also installing all of the required dependencies. If you're familiar with like Web 2 development, you can think of AlgoKit init as kind of like a yarn create or npm init, create React app, those sort of things that give you the boilerplate code for actually building whatever you're building. In this case, of course, we're building a Algorand dApp. So once we initialize from the TealScript template, you should see here we have a TealScript project, and this is a README talking about how to run it, test it, lint, all that stuff. But before we go into the actual template, I'm just going to go ahead and install the recommended extensions. Of course, these are just recommended. If you're a TypeScript developer and you have your own set of extensions that you prefer using, you're free to use those. At the end of the day, we're just working with regular TypeScript. So any extension that supports TypeScript will be supported here. So in this case, I just got ESLint in my Jest runner. And now let's talk a little bit about the structure of this TealScript template repository and how we actually get started modifying our contract and what all the different components are. So let me start with the individual files. So basically all these files, if you're familiar with web development already, these files should be very familiar to you. Basically, these are just configuration files for configuring the different tools in a repository. So for example, dev container.json is used to configure this code space, this GitHub code space. Then we have our ESLint.js, which is used to configure our linting and formatting rules, our gitignore for Git, Jest to configure our Jest tests, and then our package files for configuring our dependencies. If we actually take a look here, I mentioned that TealScript is a TypeScript compiler for Algorand, and it's installed just like any other NPM package. So if you wanted to work with TypeScript, you install the TypeScript package. Here, we want to work with TealScript, so we installed the TealScript package. And then, of course, we have our README and our tsconfig for configuring TypeScript. Now, if you're not familiar with what these files already do, the good news is that you don't manually have to edit them. The template has them all set up. Just wanted to point out that if you are an experienced developer, you can modify and leverage these files just like you would in any regular web project. So now let's get up to our directories here. We first have our test directory, and this is a test file that's going to be testing our contract. So this is simply testing our backend and testing that our contract works as we expect it to. We have some logic here and test defined. I'll come back to this file after we take a look at our contract and get a better understanding of what exactly the contract is doing. But I just wanted to point out that's where our tests are, and our VS Code for defining our extensions. And then importantly is our contracts directory. And this is probably the most important directory here. And you'll notice we have this TealScript demo file. Now this TealScript demo is just instantiated depending on the name we gave it. So when I instantiated my project, I give the name TealScript demo. And that's why you'll see it here in the file name. And of course, here in the class name as well. Whatever you initialize your project with, that name will be used throughout the rest of the project. So you can see here, I have a TealScript demo.algo.ts file. And in this TS file is my logic for my contract. So let's kind of go line by line and talking about what this contract actually looks like. So first, before we even go into the contents of the file, I want to talk about the fact that we have a .ts file. So like if you're developing on Solidity, you would have a .sol file to tell your IDE and all your plugins that you're developing in Solidity. In our case, the logic we're writing it's not a custom language, it's just TypeScript logic. So we want to end our file in .ts, so our VS Code, ESLint, all those sort of files, or all those sort of tools know that this is a TypeScript file that has TypeScript syntax in it. Now, the other thing you might notice is we have this .algo prefix as well. Now, this .algo prefix is not required. The compiler will work with any file that you give it, but the .algo allows us to separate our contract files from our regular TypeScript files. So much like how test, you have the .test, but at the end of the day, it's still TypeScript. In our contracts, we have the .algo, but at the end of the day, it's still TypeScript. So getting into the actual content of our contract, we can see here we get started by, of course, we need to import our dependencies. And in our case, we want to import the contract class from our TealScript library. And this contract class is very important. And not only does it provide us useful methods, but it's what tells the compiler what in this file is our on-chain logic. So you can see here, I have this class called TealScript demo that extends contract. And that'll basically tell the compiler that TealScript demo is a contract, and these methods should be compiled into the language that the AVM understands. And I'll show you that after we get to the build step. But before we go there, let's talk about our logic. So first notice we have two private methods. We have getSum and getDifference. The logic of these is pretty straightforward. GetSum just sums the two numbers, and getDifference will get the difference between the two numbers. And the only slightly complex thing here, well, not really complex, but it's not just doing subtraction, it's figuring out which number is bigger and then using that to order the difference operation. And the reason we're doing that is because on Algorand, we don't support negative numbers. So if we subtracted the bigger number from the smaller number, our smart contract would panic. So we want to make sure that we're subtracting the smaller number from the bigger number. So these two methods, pretty self-explanatory. And because they have the private keyword on regular TypeScript or JavaScript, if you have a private class, or excuse me, a private function in a class, that means only instances of this class can call this function. And this is the same for Algorand. So in TealScript, when we have a private method, this is basically saying only this contract can call this method. So in my TealScript demo contract, I have getSum and getDifference available, but my external clients, so if I'm calling it from a front end, I can't directly call these methods. I have to first call a public method that then calls these methods. So speaking of a public method, let's take a look and see. Here is our first public method called doMath, or first and only public method, I should say. And you can notice here, we have two numbers and then an operation. And our logic is pretty straightforward. We instantiate, or we get a results variable that's a number, and then we set the value to getDifference or getSum, depending on the operation that we passed in. So when we call this, we give it two numbers and the operation we want to perform. If it's sum, we'll get the sum. If the operation is difference, we'll get the difference. And if it's not sum or difference, we're going to reach this else branch and our contract will throw an error. Now, I should mention one thing to know about errors is that they're not recoverable in TealScript. So when you're writing a regular, front-end application, you can do a try and then a catch. In TealScript, if you try to write a try block, the compiler will complain because they are not supported. On Algorand, all errors are final and not recoverable. So just an important difference to note between TealScript and TypeScript. And so once we set a result, then we just return it like we do a regular TypeScript function. So far, all of this logic here in our contract should look very familiar to you if you're familiar with TypeScript. In fact, all of this logic is actually valid TypeScript logic. If I were to copy and paste this into a TypeScript front end or like a React front end, this logic would work just the same that it works on chain. So now the question is, we know with TypeScript if I have a TypeScript file, I run it through the TypeScript compiler, it generates JavaScript. And so now what I want to do is instead of passing it through the TypeScript compiler to generate JavaScript, I want to pass it through the TealScript compiler to generate a language called Teal. So let me go ahead and I'm going to run npm run build. And what this is going to do is it's going to do two things. It's going to compile my contract and then generate a client. For now, I'm just going to focus on this compile contract step, and we'll come back to the client in just a minute. But the core idea here is that you can see, so if we're compiling TypeScript, we would call it TSC. In our case, we're compiling TealScript, so we call it TealScript. We pass in the directory of our .algo.ts file, or excuse me, we pass in the path of our .algo.ts file, in other words, our contract, and then we give it a directory to output all the artifacts that the compiler generates. And so now if we take a look at our artifacts directory, we'll see a couple files, and the most important here is this .teal file. And this is the bytecode, excuse me, not the bytecode, this is the low-level language that is interpreted by the AVM to execute the bytecode on chain. So every contract on Algorand is ultimately compiled into Teal, and that Teal is what's given to Algorand nodes. So we can see here, we've gone from this high-level TypeScript contract to this low-level assembly-like language. Now, the good thing is that as a developer, you don't need to worry about the contents of this language too much, but it's just good to know that when we compile our contract, what we're compiling instead of JavaScript is this Teal language. So we have our approval program, which is the Teal program that's executed when we call the contract. And then we have a special program called our clear program that's executed when we want to clear state. We don't have to worry about this too much. We can pretty much just ignore this for now. And then we have some other JSON files here. So the first of which is our ABI JSON file. If you're familiar with EVM development, the ABI for Algorand is very similar. This basically just defines all the different types and methods that we are working with in our contract. So you can see here, our contract name is TealScript demo, and I have a single public method called do math. And then this has an argument called A, the UN64, and it's the first number. This is another important difference to point out. By default, Algorand numbers are UN64. TealScript supports all UINT ranging from an unsigned 8-bit integer all the way up to an unsigned 512-bit integer. Any integer over 64 bits is going to be more expensive to work with. So that's why by default, it uses UN64. But basically, this ABI file just tells our clients what our methods are, how we can call them, what types it expects, that sort of stuff. And we can see that this generated file also includes descriptions. And those descriptions come directly from our type.doc header comments. So not only do these comments help us, so if we go in our code, we get the comments for our methods that we define, but it also defines our code, our descriptions in our ABI JSON file, making it easier for people to read the JSON file and understand what's going on. Now, the other important JSON file is this TealScript demo.json. And this is basically a superset of our ABI file. So we have our ABI file, so everything in our ABI file. We also have other things like the source code and information about how we can call it and what the state in our contract is. Now, again, we don't have time to go into all these in depth, but just want to call out the differences between all these files. Now, finally, before we get into messing around with logic, we have this source map file. And what this basically does is it'll map a line of Teal to a line in our contract. And then it also has these program counters. So when we execute on chain, we can see exactly which line is executing at what time. Again, we don't need to be directly modifying any of these files. It's just good to know what they all do. So we've gone over our compact or contract compilation, and we now have the code. So we have our TL code that we can give to a node in order to deploy our contract. Another question is, how do we actually do that? How do we actually start interacting with our contract? And that is exactly where this clients folder and this client build step comes in. So we can see here that we also did a generate client. And what this did is it took in that TillScript demo JSON. So we first compiled our contract to artifacts, and then we took an artifact and generated a client. And if we take a look at the client we generated, this is just a regular TypeScript client. So, or excuse me, regular TypeScript class. So this has a bunch of lines of code that is basically the boilerplate for interacting with our contract. Now, to see how this is actually used, what we can do is we head on over to our test, and we can see here in our imports, we're importing the auto-generated client. So in order to interact with our contract, all we had to do was run npm run build, and that gave us this client that gives us all the boilerplate code for easily interacting with our contract. So now if we go into our actual test logic here, we can see instantiate what's called an app client by simply instantiating this imported class. So this TillScript demo client was automatically generated for us when we ran npm run build. And to actually deploy it to the network, we simply pass in some metadata. So we're telling who's going to be deploying the contract and how we're going to point to the contract. If we say our contract has an ID of 0, that's basically saying this contract doesn't yet exist. And then to actually deploy it on the network, it's just a single line of code. We're going to call app client.create and then call our .create application method. And so what this is going to do, it's going to deploy our contract on our local network. So what do I mean by local network? If we come back to this algokit localnet start command, you can see here what it's going to do is start a bunch of containers that are going to run a local instance of the Algorand network. And if I want to verify that it's actually running, I can run algokit localnet status and see that I do indeed have a local network running. And what this will allow me to do is quickly test my contract without having to use a testnet or worry about testnet dispensers. It's all being run locally through Docker. So once we've deployed and created our application, we can now see that we can call our methods. So we can call do math, pass it two numbers in our operation. And then we can also do the same thing, two numbers in our operation of difference. So if I do an npm run test, what we'll now see is our test file will be connecting to our local network, and then it will be running these commands. Oh, it looks like our test timed out for some reason. So let me go ahead and that's bizarre. Okay. Not sure why the async functions didn't test, but for the sake of time, I'm not going to go through it, but you can see here that we've now advanced our local network to 2 rounds because we sent 2 transactions. And what we're able to do when we run our test is verify that our test did indeed pass like we expected to. So we wrote our just functions just like we expect them, or just like we write them in a regular TypeScript context. So to summarize, we have our TillScript contract that's just native TypeScript. We compile it to generate these artifacts and this client. And then in our tests, what we can do is we can import that auto-generated client and then make sure that we have instantiated our client and deployed it. and then we can go ahead and test our logic and make sure that it's actually happening on chain the way we expect it to. So the nice thing about Codespace is that this is all happening locally in our code space, and we didn't have to install any extraneous dependencies. So again, to recap, to get started, if we come to Algorand Bootcamp, head on over to our beginner BN repository, and you can start a code space based on this repo, and you can get started following along the bootcamp. Of course, today I haven't gone too in-depth into these concepts. The bootcamp is when you can really start to get your hands dirty and learn more about developing on Algorand. And of course, all of the source code is available here. And then we have video recordings for all the sessions. So we had 4 hour-long sessions, and very shortly we'll also be posting an individual video for each step of the bootcamp as well. And by the end of the bootcamp, if I go here real quick and I take a look at our bootcamp here for our final product, we'll see here that we have our TealScript directory, but we also have a front end written in React for interacting with our contract. And then in the bootcamp, we're writing a DAO. So by the end of the beginner bootcamp, you'll have a fully functional DAO that you can then interact with using React. And this is a great starting point for starting your own project. So by the end of the beginner bootcamp, because you have both the front end and the smart contracts, you're now ready to modify them to your own project that you want to build for the Buildable Hackathon. So this is a really great way to get started building on Algorand. So of course, you want to be sure to come to our Algorand, come to our Algorand Bootcamp org and follow it, star the repos, and get the latest up-to-date content through them. But some other good resources, so I mentioned the developer portal, that's developer.algorand.org. And what's also another good resource is if you go to discord.gg/Algorand, this will take you to our developer Discord, and it will give you access to myself and a bunch of my other colleagues that work at the foundation there to answer technical questions and questions about the buildable. But it also is a good way to connect with other people in the ecosystem, learn from experienced builders, find teams, discuss ideas for the hackathon, all that sort of good stuff. So definitely check out our Discord. That is one of the best resources for Algorand developers. And then finally, if we go to github.com/Algorand Foundation/TealScript, this is the source code for the TealScript compiler. And if we come to tealscript.algo.xyz, we have our documentation for TealScript that goes more in depth about how TealScript actually works. And I should mention that TealScript, we can see here, TealScript is currently in development. We're going into production very shortly, so within the next couple of weeks. But in the meantime, the documentation is currently being worked on. So if you go to the documentation, you feel like something is missing, feel free to let me know. I'll be happy to help you personally. And then, of course, make sure it's added to our documentation for other developers. So that concludes the content for the beginner bootcamp that I'll be giving today. And what I want to do is I just want to make it clear that this is only the beginning of the content. And I really recommend developers to go ahead and come to our bootcamp repo so you can engage in our beginner and in our intermediate courses. And this is really, like I said, this is really the main place to go for learning on Algorand. And so what I want to do is if there are any questions, I'm happy to answer them in the remaining time we have. Otherwise, we can continue kind of playing around with TypeScript and TealScript and showing you how that works. So let me check
Yeah, there's actually one question. So there's a audience ask, nice to see Tail script instead of Python, but do we still need to do the sandbox setup thing?
Yes. So on Algorand development, in order the typical recommended way is developing against a local network, which is sometimes called the sandbox. So if I come back, let me find my right. Here we go. So if we come back here, the sandbox setup is what we did when we did AlgoKit localnet start. So this localnet start is basically replacing the former functionality of the sandbox tool. So at the end of the day, this is still using Docker to run our local network, but we are using AlgoKit to manage our Docker instance or Docker containers rather than the sandbox tool. So you still need Docker installed and you still need to run a local network, but it's made a lot easier with AlgoKit. And I should also mention that because we're in code space, we didn't need to manually install Docker or start our local net was started automatically. If you want to develop locally, you have to make sure you have Docker installed and you, of course, start your network with AlgoKit localnet start. And I should mention that it's not required to use a local network. It's just what we recommend using because it's you don't have to worry about dispensers and like funding your testnet accounts when you're testing your contract. But it's also nice because you don't have to worry about block times. So in Algorand, we do have quick block times. They're around 3.3 seconds. But when you're testing, like in our case, we only have 2 tests here, so it wouldn't be too bad. But you can imagine a production contract, you might have like hundreds of tests, and you don't want to wait 3.3 seconds each time. So the local network, each block is instant. So as soon as you send the transaction, it's approved, which of course isn't the behavior that we see in our public networks. So yes, we still develop locally. It's not necessarily required, but AlgoKit makes life a lot easier for you when developing against a local network. Okay, so I think...
Yeah, I think that's the only questions. So feel free to continue the part that
Okay,
you
great.
want.
Yeah, so what I'll do is kind of show you some of the core Algorand concepts and resources to learn those concepts that are important for to know for Algorand development. So as we've seen here, right, we can see that all of our logic is just a regular, TypeScript content. This is just, if you know TypeScript, you'll understand this code. And the nice thing, like I mentioned, that this is all about TypeScript code. We could copy paste this in JS Fiddle and it'll run just fine. However, of course, because we're working on blockchain and not in a browser or in Node, there are some unique things to Algorand that are in TealScript. And so to learn about these unique things, the best resource for that is if we come back to tealscript.algo.xyz and we come over to our guides, you can see here some of the guides for TealScript specific things, Algorand specific things. So probably the most important thing to talk about and most important thing to think about when developing your application, but even before that, thinking about your architecture, is how you want to use on-chain state. So on Algorand, every application has the ability to save state to the chain. So when I deploy an application on a chain, that application has a unique ID. Whenever I want to call it, I call that ID. But that ID, that application instance, can also save data. So if I want to have, let's say, a counter on chain, I could have a counter that is incremented each time I call the contract. And to do that, I use what we call contract state or contract storage. You'll see throughout this documentation and just in general, we use the term storage and state interchangeably. They mean the same thing, right? So If you ever see storage or state, just know that basically means saving things on chain. And on Algorand, there are kind of 3 primitive storage types, and they each have pros and cons. Kind of the key is that we have, or kind of the high level, I should say, is that we have our global state, our boxes, and our local state. Now, again, each of these have their own pros and cons to under the hood, like what it means for your architecture of your app. And I'll be getting more into that in the intermediate session. But for now, I just want to point out the interface for how we actually interact with these things. So basically, typically like in a like Web 2 app, if you have your front end code and you want to save something, persistently, you either like use a cookie if you just want to do it locally, or you call out an API that has a database as a backend. Of course, when we're on chain, we can't, directly use an SQL database or cookies because we're executing on chain. Instead, we have the database of the blockchain. So every Algorand node is just running an SQL-like database. And so the contract is essentially an entry in that database, and we can save information to that entry in the database through our state. So basically, if I want to save something persistently on chain throughout multiple contract calls and throughout the lifetime of our contract, we can see here that I instantiate a key using this global state key. So what this is doing is basically saying, I want to have one piece of state in my contract. I want that piece of state to save a string. And to actually use that, you can see here in this example, let me zoom in a little bit, sorry about that. You can see here in this example, so we did global state key. This is going to hold the string. And we can see here to set the value, we just call this .sumKey.value is going to equal whatever value we want to. So now, as we can see in our comment, on chain, some key is going to point to our value. So instead of passing our value to a database or to the user's local storage on their browser, we're passing that key to our state, and that is going to save it on chain. Now, one of the nice things is that, so this is just creating a mapping. Our sum key is going to hold a single value. Now, the other way that we can use state is through what we call maps. And if you're familiar with Solidity, this is very similar to a mapping. And what this is basically doing, it's creating a mapping between a specific key type and a specific value type. So in the above example, we have some key is a global state key. So we just have one key called some key, and it's going to save a string. But now we create a map. And again, the difference between box and global state, we'll get more into in the intermediate session. For now, let's just focus on the fact that we're using a map. We can see here, we're mapping an address to a string. So instead of having some key be a hard-coded string in our contract, we're now simply using an address as a key, as one of the keys in our map. So we could see, in order to set the color, in this example, we're setting a favorite color for an address. A person will call set color, pass in their favorite color, and then in order to set it, we call this color. We specify the key. In our case, it's going to be the address of our sender. And we set the value equal to whatever chain they pass in. So now on chain, the sender's address, so the key is the sender's address, and the value is whatever color they pass in. And so using these two concepts, our state keys and our state maps, we can now either dynamically store data with our state maps or statically store data to a specific key with our state keys. And this is probably the biggest fundamental difference when it comes to the architecture of Web3 Algorand apps versus the architecture of Web 2 centralized database-based apps. And again, of course, because we have all these different primitives, global, local, and box, there are different pros and cons to using those. But the key is that you can either use both a direct single key or a map. And if you want to learn more about this, you can see here in our documentation, we have a couple more features available when defining state. And also to this documentation page, there's a link here. So to read more about these storage types, if you come to the developer portal and follow that link, it'll basically give you the details of the differences between all the different kinds of state. Again, in our intermediate session, I'll give even kind of more of a high-level overview of this and kind of the way you should think about adding state to your contract. But this is a great resource for getting in-depth information about how state works. So now what I want to do is if I come back to my, so where was I? I was looking at my on-chain storage. The other important thing to note about Algorand contracts is our lifecycle methods. So the CRUD methods, creating, updating, and deleting. So by default on Algorand, every contract has the ability to be updated and deleted. So this is a bit different than EVM chains. Now, with TealScript changes that behavior and makes it so that every TealScript contract by default cannot be updated and deleted. So at the protocol level, if I already just deploy a contract that does absolutely nothing, anyone can update it, but TealScript adds in logic that protects update and delete logic. But if, as a TealScript developer, I want to define logic for my create, update, and delete methods, I can go ahead and do so. So I can see here, if I wanted to create a method to execute specific logic when I create my application, I can go ahead and do that. So in this example here, you can see I've created this contract called counter that has a counter in our global state. And when I create my application, as part of that constructor, this is basically defining a constructor for our class. We can see here, we are calling void, or excuse me, we are calling a void function. And all this void function is doing is setting the value of our state to the number we pass in. So this is very similar to kind of the architecture you would have for a regular TypeScript class, where you have some property for the class, and then you instantiate that property in your constructor. Except this case, it's a special method called create application, and our properties are just pointing to our contract state rather than our internal properties of our contract, excuse me, of our class. Now, very similar approach works for update and delete. So we can see here in our update example, so we have our create application method that is the exact same before. But we also have our update application method. And what this update application method has is some logic. It's basically ensuring that the only person that can update it is the app creator. So when this method is called, it'll see who is sending the transaction. And if the app creator, or if the transaction sender is the app creator, this assert will check out and it'll allow the method to execute. Otherwise, it'll cause our contract to panic. So this is an example of not only how we can allow our contract to be updated, but how we can protect our contract from updating. And of course, here you have logic for checking the sender, but you can implement any sort of logic you want in your update method. So if I wanted to say, only allow this contract to be updated after a month has passed, or after it holds this asset, or if the caller holds this asset, I can do all of those sort of things. The same exact thing applies for delete. Instead of update application, I define a method called delete application, and this will implement a method for deleting our application. And again, we have the same kind of check, only allow this application to be deleted by our transaction sender and by our creator, by verifying our transaction sender is the same person that created the app. I also see here We have some different lifecycle methods that are unique to Algorand. Again, we'll be covering these more in depth in the intermediate session, but this is just dealing with how we clear state from our contract and then how we define more granular control to our methods. For the most part, as beginners, you don't have to worry about these, but the basic documentation is here for in case you need it. Now, finally, the last unique thing available in TealScript that is unique to TealScript and not something you would do in regular TypeScript functions is what we call inner transactions. So by default on Algorand, of course, any account can send a transaction, and this is no different than contract accounts. So when we create a contract on Algorand, it has a unique ID, but it also has a unique address. So when we're calling a contract function, we call the ID. And when we're sending assets, so sending algo or sending a token, we send it to the address. And in particular, that address can not only receive assets, it can also send assets via what we call inner transactions. And so we can see here that we have a couple different transaction types that is supported by Algorand. So of course we can send a payment. And this means sending, some algo to another account. We can also transfer and create assets. So on Algorand, assets are a primitive feature of the blockchain. So like on EVM chains, you have ERC20 contracts. On Algorand, we don't have contracts for tokens. They're just native primitive assets to the blockchain. So we can send transactions to transfer them, create them, configure them, freeze them if that's enabled in the asset. And then, of course, we have transactions that we can call apps. So within one app, we can call another app. And then finally, we have these online and offline registrations. This is for participating in the network. Most contracts, you don't need to worry about these, but they are available in case you wanted to create some sort of staking contract. And what's also supported on Algorand layer 1 is this idea of atomic transactions. So not only can you send an individual transaction, but you can group a bunch of transactions together, and that'll allow each transaction in the group to read information about each other. So if you call an application in a group transaction, that application can then read all the metadata and information about other transactions in the group. So all of that is documented here. And again, this is just kind of high-level documentation for the nitty-gritty details. You can go to the bootcamp, and then we're also working on full tutorials for our documentation as well. But of course, we don't yet have that published yet. So one last thing to point out, actually, before I forget, is this type section goes over some of the unique types that we have available to us in Algorand. So as I mentioned, we support unsigned integers ranging from 8-bit to 512-bit. We support fixed decimal numbers ranging from 8-bit to 512-bit with various levels of precision. We have tuples, dynamic arrays, static arrays, and booleans. And we also support objects, much like structure functionality or struct functionality. And you can read about all the different ways that they actually work under the chain in this documentation. Some of the ways, there are some restrictions to how you can use arrays. That will be documented here in this documentation page. So not everything you can do in TypeScript, you can do in TealScript. For example, you can't use dot for each. You have to manually write your dot for loop, or you have to manually write a for loop to iterate over an array. Small things like that we're still working on implementing in TealScript. But this is kind of a good page, kind of an idea of what's supported. For numbers explicitly, there's some unique things to know about numbers and how they work. This is a good page to learn more about that. And then here is the page on arrays and how they work and what are some of the limitations with them. So that concludes the additional content to go over. I see here that we have a question. Is it possible to create an entire dApp in CodeSpace? And the answer is yes. So if I actually come over back to my CodeSpace, and what I'm going to do, we'll git checkout P113, when I come to my front ends and do an npm oops, and we can see here that we now have a front end for our application. And I think this will work. I might have to open the ports. Let's see. I do an npm run dev. We can now see a very basic front end. Oh yeah, we didn't instantiate. So let me do a, oh, I'm the wrong. Git bootstrap all. It's going to go ahead and set up my environment for me. And then I do an npm run dev again. I'm back here. We can see here, we have a very basic UI. So in the code space, by the end of the beginner bootcamp, you'll have a fully functional DAO contract with this UI all directly integrated in the code space. And in this case, we're just connecting to our local network, but AlgoKit also makes it very easy to switch from our local network to mainnet. So in CodeSpace, if you wanted to, you could write your entire production application. Should be noted, as I mentioned, CodeSpace only has, I think, 60 hours for free for each user. So you will hit that limitation. So eventually it is recommended to set up your environment locally. I should actually mention, good resource on doing that is if you go to developer.algorand.org and you search AlgoKit Quick Start Guide. This page will tell you we have videos and then information about how to set up AlgoKit locally. So when you're ready to get set up locally, you can go ahead and do that. Okay, I think that covers all the questions, and we're coming up on a wrap on the time. So I just wanted to mention, again, some resources, our developer portal, our Discord, and if you have any questions specifically on this content, go ahead and ask in the Discord or reach out to me specifically. On the Discord, my handle is Joe-P. Feel free to reach out to me. I'm also on Twitter, Joe_Polny. Happy to answer any questions you might have, whether it was about this content that we went over today, or just general questions you have throughout the hackathon. We will also be having office hours that are hooked up to my calendar. So when you book, you can either book with myself or my colleague, Steve, who's based in Europe. I'm based in the East Coast in the US. So depending on what time zone you're in, it might be, you might get one of each of us, but we're all there to kind of help you and support you. So even outside of these workshop hours, we're there to answer your questions. So Chris, I think that covers all the content I planned on covering. I don't know if there's anything else that you wanted me to cover before we wrap up here.
Yeah, amazing. Thank you very much, Joy, for this very detailed and useful workshop as the very first workshop to kick off the whole hackathon. I believe the whole sessions have been super helpful for developers who want to build on top of the Algorand. Just want to quick mention that the hackathon have already kicked off. And developers and audience, you can definitely take your time. But if you have already have an idea or even have started to coding or like even launch your MVP already, do not wait till the last minute to submit your project, just to avoid some like might be technical difficulties or like something like that. Because we observed a lot previously. So definitely don't try to wait till the last minute. Try to engage from the beginning. Like Joey mentioned, that you have many ways to approach. If you encounter difficulties on submitting process, you can definitely reach out to DoraHacks team, our ops team and technical teams will 24/7 standby, since we have different teammates located in different time zones. So definitely let us know. And we are very looking forward to see all of the upcoming submissions, all of the upcoming talents who will join the hackathon and events. Yeah, and I think that'll be all. Thank you again, Joy, for your content. Super helpful, and thanks for all of the audience who engaged, who asked the questions, and who watched the live stream. And the next workshop will be hosted on 26th this week, which is Thursday, and hope to see you guys there. And yeah.
All right, thanks, Chris, and thanks everyone for watching.
For sure. Thank you, Joey, a lot. Thanks, guys.
My pleasure.
Cheers. Have a good one. Bye. Yeah, I think we